When you are removing a small amount of the water, then it is entering into the phase of drying. In the evaporation, you do remember, you are going to remove large amounts of vapors to convert your diluted product into concentrated product. So that is actually you are making a liquid, the liquid which is converted into a concentrated from a diluted one. In the drying, this concentrated product which is present, you are removing a small amount from that also, and you are taking a small amount of water or a solvent from solid, and you are making it doing by application of the heat. So this is in the drying. It is a removal of the small amounts of water or other solvent from a material by the application of heat. Now, water is a generally which we are going to use. It is a universal solvent, but we are also going to use other solvent like maybe acetone or ethanol or methanol or any liquid which we are using in our pharmacy. We need to remove them. So it need not be always water. That is one thing you need to remember. Another one is you need to put in the definition small amounts. If you don't write these small amounts, then your definition is going to be wrong. It will be merged with evaporation. So don't do that. So drying is defined as the removal of small amount of water or other liquid. So other liquid is also required to be mentioned because sometimes we are going to have other than water also as our solvent. How we are doing by the application of the heat. What the heat is going to do here? It will break the intermolecular forces between the liquid and make it entering into the gaseous state. Gaseous state will have a highest diffusion. This is diffused out of the solid and makes the solid dry. It means in the drying, your starting material is a wet solid and your end product is dry solid. Where do you apply this? Why you want to use this? So I have already told you it is very much important in our pharmaceutical industry when you are doing it to preserve, because most of the solids when they are wet, they tend to degrade. So if you want to preserve them, you need to dry them. That is one aspect you need to understand first application. Another one is improved characteristics. Improved characteristics, see, for example, it is a better flow. Flow wise, it is having improved characteristic. One characteristic is a flow. So it will be having a better flowing is required in our pharmacy because it is required to enter from hopper to individual powders, which is in the tablet punching machine or in the capsules in the case of capsule manufacturing. So this is actually that is required. Another one is preparation of bulk drugs. In the preparation of bulk drug to have this, to remove the final solvent where we are making it to dry form by removing the solvents from the reaction mixture which are used in the reaction mixture. So we are after filtering it and removing the wet solids and drying it. By drying, we are removing the wet and we are making it a completely dry. This is obviously last step of our bulk drugs business. So this will make the improved handling. Improved handling means your handling cost will be obviously getting reduced after you are making your drying happening because it is reducing its weight. So your transportation charges will also be less and you can easily transport one place to another place. Dry material is easy to handle. That is making other advantages of this drying. Handling in the sense, storing, that is good. Transportation, it is good. It may be used for the one place to another place, one reaction to another reaction, one place from the hopper to individual plots or the dice. So it is handling is improved. If it is not there, what will happen? What is the improper handling? It will stick to the surfaces, and it makes the sum of the amount it is attached to the substrate or the material containers. So you are going to lose some product with that. So dry material is obviously safer in that particular case. Whenever you are entering into your drying, you need to learn the concept of bound water and unbound water because it is a fundamental we need to learn. So this background, it involves each material what we are going to deal, it is going to contain bound water, not only the water, bound solvent also you can call. If it is a solvent means it is other than water. Bound water is the minimum water that is held by the material that exerts an equilibrium vapor pressure less than the pure water at the same temperature. What does it mean? Say, for example, if you have got a keeping water, so when you are keeping the water, it is free to get evaporated. When it is having free to evaporate, then what will happen? You are having some atmospheric pressure. So then atmospheric pressure, when it is bound present in the bound form, then what will happen? Its atmospheric pressure will be lesser because it is bound by the solid. When it is bound by the solid, the attractive force between the solid and the water, it makes the less atmospheric pressure which is produced by the water in the same situation when it is kept in the pure form. So you keep the solid and pure water separately, it will exert more atmospheric pressure. When you are merging the water with the solid, if the water is bound to the solid, then what will happen? You are going to have a less atmospheric pressure because the water is not free to get evaporated. That is the reason it is producing less atmospheric pressure. What does it indicate? It takes more energy to break the bond between the solid and the liquid. It means bound water is going to give us a trouble in the drying because it is taking more energy. So that is the first thing you need to know. The second one, remind, is it is easy for us as being a pharmacist, it is easy for us to use unbound water. Unbound means it is not having attractive force with the solids. It is present as if it is present is in the void. It is not bound to anywhere. So it is the amount of the water held by the material that exerts an equilibrium vapor pressure equal to that of pure water at the same temperature. That is the reason it is not having any differences in the atmospheric pressure when it is kept in the solid or you are keeping it out without any solid. So the unbound water is easy to get evaporated and it is going to cause less trouble to us. So if the water is present in the unbound means our job of drying is very much easy. At ease you can do it. But in the bound water you are going to face the trouble because your water is having attractive force and bondage with your solid. It will take longer time. Sometimes your residual water or solvent, it will make you tough for the further drying. So you need to employ different equipment to handle this bound water. Generally, unbound water is existing the voids of the solids. Voids means the spaces between the solids. That is when the solids are kept, if it is present in the spherical or any shape, so there is a gap between one solid to another solid. That is actually a void. Of course, you are also having a spaces called as a pores. Pores means the space which is present inside the solid, like a pore. So the pore is also going to filled with liquid. So if it is present in the unbound, there is no problem. But pores, if it is having a curved path, it takes a little bit more time. So unbound water, it is not having a bondage. That is the reason it is going to have a ease of drying and not problematic to drying process. Material, they tend to catch the water when you are keeping in the open atmosphere. They tend to absorb the moisture. So it is say for example, in winter, in rainy season, your table salt will get moist with atmospheric moisture and it will become wet. It does not mean that in the table salt of your table, somebody is adding a water. Nobody will add the water. The material itself, hygroscopic in nature, they tend to absorb the moisture. You find that salt watery and wet. So this is the hygroscopicity. Most of the times, if you are keeping a glycerin bottle outside without closing the lid in your laboratory, so the viscous liquid of glycerin, it will become that is less viscous. So because it will tend to absorb the moisture. So when it is absorbing the moisture, what will happen? It is going to having a high moisture content. This tendency of absorbing the moisture from the atmosphere is actually called as a hygroscopicity. So these hygroscopic materials, they tend to absorb the moisture. They are present in the capillary cells, cell fibers, and physical interactions. They are present to have a bound water. And vapor pressure of the solid is lesser than the vapor pressure of the pure water. That is the reason it takes more temperature to get dried and more time to get dried. Another one is actually called as an hygroscopic material. If you keep anything, if you are keeping sand material, sand, simply when you are going to beach or you are finding a sand. it is the material, they don't hold any water, just water is present in the voids. Such materials, what will happen? They contain the water in the unbound manner and they don't have any interaction. So that a vapor pressure of that particular solid is equal to that of the vapor pressure of your pure water. So this is actually what you need to distinguish between these two. This is actually a fundamental principle for the determination of which equipment I am going to use. What is the equipment I am going to use for my drying unit operation, depending upon how much quantity of my material is having a bound water that is going to give me a trouble. For that purpose, I need to select a better equipment suitable to that particular fixture. So this entire class, what you are going to have now, it will make you understanding these concepts, and you are able to select a good dryer for your process, and you are able to indent in case of when you are starting any pharmaceutical industry, you are in a position to indent a better dryer and make your owner to purchase with a scientific background stating that this dryer is going to suit our particular purpose. So this is actually what we require to know. So now I have already told you this is equivalent to atmospheric pressure, the concept which is making it. We need to understand some more terminology before entering it. One is called as EMC. EMC is also called as equilibrium moisture content. What is equilibrium moisture content? It is the amount of the water present in the solid which adjusts the vapor pressure equal to that of the atmospheric pressure surrounding it. Say for example, if you have got some water in any solid or any solvent in a solid, it is exerting the same as that of your atmospheric pressure, then there will not be further evaporation. Generally, there will not be any further evaporation because its vapor pressure and atmospheric vapor pressure is same. So there will not be any differences in the vapor pressure of that particular liquid in the atmosphere. So it won't get evaporated further. So the liquid will be stand still. There will not be any dry. It means it is the amount of the water present in that solid in that particular critical amount. The vapor pressure of that solid, which is the liquid which is present in the solid, is equal to the vapor pressure of the atmospheric surrounding it. So at that particular case, you don't have any further drying. Your drying will not be there and it will be standstill. Now I will be asking you one, making you remember one. In the rainy season, when you are making a wet cloths outside for drying, it takes longer time. So because in a sunny time, you will be making the same cloth, wet cloths, they will be getting dried immediately. But in the rainy season, your wet cloths will not get dried. It takes 1 day or 2 days. You need to keep longer times. Why it is happening? Reason is, so the vapor pressure exerted by the cloth, what you are keeping outside, is same as that of the atmospheric vapor pressure of water. So atmosphere is also having a rainy droplet, so it is having full of vapors of water, that is humidity. Then it won't go, the water from the cloths will not go, so it will not get dried, it takes longer time. It means in our pharmaceutical industry also, when you are drying any material, if that material is exerting a vapor pressure equivalent to the vapor pressure present in the surroundings, then there will not be any drying. It means if you are working for 10 shifts also, you will not get a material dried because you have reached the EMC. This is actually what you need to know as a fundamental before going to the drying topic. So there is another terminology you need to learn here is free moisture content. What is free moisture content? Free moisture content is the amount of the water that is free or easy to evaporate from the solid surface. It means it is having an excess and it is not bound and it is freely available for the evaporation without holding by the solid. This is actually making water easy to evaporate without any problem from the solid surface. This is actually a concept of a free moisture content. It means when you have got a free moisture content, if the solid is not reaching, the liquid present in the solid is not reaching EMC, your drying is very easy and free. You don't have any trouble, just it will get evaporated without much your intervention. So this is actually called as a FMC concept, that is free moisture content. Why I am telling little bit detailed, you will be getting 2 marks question in PCI syllabus. Define FMC, define EMC. Like that you will be asked. Sometimes they will be asking define drying and EMC. Like that you are going to ask. Or sometimes you will be asked the material like what is hygroscopic material? What is the significance of this in drying? 2 marks question. Hygroscopic materials are the material they tend to absorb the moisture from the atmosphere. And what is it significant in the drying? It is very difficult to dry them because they are catching the moisture. Even if you dry them also, if you keep it in the open place, again they get moisture. So again you need to take them to drying. What does it mean? In the drying process, when you are handling equilibrium, whatever the hygroscopic material, immediately after drying you need to put them in the closed containers, tightly packed containers. In that case, your drying will be purposeful. So it is very critical when you simply drying is not sufficient. Again, it is catching the moisture means your attempts are gone. That is the reason. What you require to do, what you need to have, whether it is a bound water or unbound water, whether the water is present is reaching the EMC or FMC, or it is containing the material present in the voids, or it is present in the interaction with the material. So these are all the aspects which we need to understand better. Then you can see that my drying is smooth or it is going to get a tough time. And there is some more concepts which we need to understand here. I don't want to touch up this now because these are all the things which we are going to learn in a due course of time. Let me go to next step is called as stages of your drying. Drying, it is having a different stages. If you see in this particular diagram, x-axis is having a free moisture content and the rate of drying on the y-axis, which is present in the y-axis. It is region, it is containing A dash to A naught or A dash to A, or it is starting from A or A dash, anything which is having, and reaching to the B, from B to C, C to D, D to E. So it is a diagram which is present. Generally in the x-axis you have got a 0 starting, but here you have got your starting point is the x-axis and going to the 0 went to the right. So this is reversal of regular graph what you are making it. It is containing 4 stages. One is initial adjustment. Initial adjustment means you are drying whatever the material, it is either losing the water or attracting the water. So it may attract the water and making further wet. It will lose the water, it will be making bruise. So that is the reason A and B is rising or falling. Both will be existing in the, it is actually up and down, it is fluctuating in the initial stage. That is called as the initial adjustment. It means your evaporation of the water and condensation of the water and falling back of water is taking place in this stage. This is the initial part of your journey of drying. The second stage is constant period. Constant period means the rate of drying is same for particular period of the time. When it is present in the FMC, this will be happening and freely the material is having, if the area is constant and the drying is also keep on constant, and you will be having similar rate of drying. Then you will be coming to the after point C, the critical point. You are going to have C into D, that is the first falling. The drying rate is going to be reduced. This will happen because of your water is entrapped within the solids. It is taking some time to come out and diffused out. So this is one aspect. After that, you are going to enter into the fourth stage, that is D, that is second falling period. The moisture content is further delayed. That is actually the drying is further delayed, rate is further delayed because it is forming a barrier by the solid by making a hard solid material which is already got dried. It is not allowing the water inside to come out. So it is further delaying the rate of transmission of the water from the center. So this is actually a 4 stages, and you are going to have the C is actually what this point is called as a critical point. This is the point C, which I am showing in this. That is CMC, critical moisture content. Don't get confused this with FMC and EMC. These are all the terminologies. I am going to tell again this, don't get worried. you will not be able to understand in first theory itself. We are going to have this in the practical also. There we are going to get the data of all this. Then you can tell me what is the CMC for your particular material you have got. Whether you have attained EMC or not, you are going to tell me. So here, just to understand the concept, CMC is a critical moisture content. Critical moisture content is the stage, and after that it is going to enter into the first falling and second falling. That is the one which we are going to see. And the point E in this particular is actually attaining the EMC. EMC means equilibrium moisture content. At that particular one, drying rate is 0. You don't have any drying. So this is the one which you just memorize it. We will see later. Now we will go back and see the definitions of some of the things which we need to see. Calculating it. First, these are loss on drying. Loss on drying is the mass of water present in the sample in the kg by the divided by the total mass of the wet sample. Wet sample means water and dry solid both together. This is actually a loss on drying, and multiplying with 100 you will get a % loss on drying. So this is the % loss on drying. Generally, it is given by your boss. How much is your end point in the drying? Either it is 1% or 2%, like that it will be given. The second one is the last one. If you are seeing here is the drying rate. What you have seen in the previous slide, the drying rate we have kept in the y-axis. This is the one which you are going to keep. What weight of the water lost from the sample per unit time, per unit solid, per unit area. So this the laboratory, this Almirall-like structure you are finding, that is actually what the simple tree dryer. Similarly, which you are seeing in your microbiology lab, that is actually incubator. Don't get confused with incubator and dryer. Both are having heating purpose, but in the incubator you have got a temperature adjusted to 37 degrees like that. But in the dryer you have got a temperature going up to 200, 250 also. So that is actually a differences. Appearing wise, both are appearing same, incubator and this, but you are going to have a drying higher temperature. Incubator is having a lower temperature. So that's what you are seeing. If you see here, you have got air inlet from the extreme left. You are having this. Heater is present in the left. That is actually a coils which are present inside that particular dryer and supplying the heat to the material which is present in the tray. If you see in this diagram, you have got 4 trays. First tray, second tray, third and fourth. These 4 trays are having certain area. If your dryer is square type, you will be having maybe 3 feet into 3 feet, 9 feet square feet of your material. You can keep at a certain thickness. You see here, this material has got somewhat this place. This is the place it is having very thinner in nature, the material. In this tray, it is having very thick. So if you see here, you can accommodate some thickness. Maybe it is a 1 centimeter thick or 0.5 centimeter thick or 2 centimeter thick. You can keep it. So the trays which are equipped with some material of construction, that is either maybe a steel or it may be a copper or any inert material which is not going to cause the damage. Okay. Now you are having a fan here because it is actually called as a simple tray dryer. Tray dryer is also acted hot air oven. So this is a hot air. This hot air oven, this is also synonym is a hot air oven. The hot air is coming by the making of use of a fan. This fan will circulate the temperature throughout its chamber by making your circulation of the air. So what will happen? It takes the air inlet, air will be going in this arrow and makes this fan and entering into the air to the above the first tray, and it takes all the moisture and going to the second tray. Then it is going above the third and fourth. From the fourth it is going out, air outlet. So this is actually a journey. So you will be having the first part is actually called as a construction. In the construction of your tray dryer, you have got heater and fan and trays. All are enclosed in a structure, that is a cubical structure which is having a door in front. You can keep your trays at a particular height. So depending upon your requirement, you can keep 10 number of trays, or it may be a 5 number of trays. So you can keep one after the another. Okay. So by the switching of your fan, the hot air will be circulated around the your trays and takes the moisture and going out, and fresh air will be entering and keep on taking it. It means you are creating unsaturated zone in the oven by the circulation of the air. Say for example, if you don't switch on the fan, what will happen? If you don't switch on the fan, what will happen? Your air is completely saturated with water vapor. After attaining certain times, EMC is attained, there is not any further drying will not be there because it is attaining to EMC. So after attaining EMC, you don't have any drying. That is the reason you are circulating your air by means of a fan. When you are making this, the air will sweep off your whatever the moisture which is present, throwing it out of your oven. And you are getting fresh air. That air is unsaturated with water, and it again takes, like you are creating a unsaturated zone by this particular fan. So you are making your drying taking place with ease. Now we will be going back and seeing what is this. In the tray dryer, hot air is continuously circulated. How it is circulated? It is by the fan. And forced convection, it is not a natural convection. We have already seen in the heat transfer, there are two types. One is a forced convection and another is a natural convection. Forced means by using a fan or a pump or a stirrer or a mixture, we are creating a convection. That is actually called as a forced convection. Okay. Now, because of this forced convection, heating takes place to remove the moisture from the solids. They are already wet. The material is placed in the trays. Simultaneously, the moisture is removed partially. So it is partially. This entire thing will not be there because when you are seeing in this particular journey, it is taking, entering, again it is coming and it is going out like that. So some amount of the moisture is always going to be present there, but you are removing partially at the end of particular period or a time. You are removing entire moisture. At that particular time, you need to stop your drying process. Your end point, how will you know it? You remove the material from the bed. The bed is present in this particular trays. So you are going to remove the material 1 gram or 2 gram depending upon your SOP, and see that how much moisture is present in that. If it is lesser than your required moisture, then you can stop it. So in this particular journey, you need to understand two aspects. One is construction, another one is working principle. These two we have already seen, the construction part and the working principle part. In the construction part, you have got heaters and trays, fan, and you have got a heat inlet and outlet. And of course, in the fan, you have got a screen. That screen will prevent the dust to enter into your product. That is actually obviously present. So the screen, we know that it is not a sieve. Screen means the porous plate which is containing holes in it. So it will allow some amount of air, but not the solids to go enter through them. This is actually a concept of screen. Now, you are having this air supply making the removal of the moisture as and when they are getting evaporated, makes the removal of the moisture continuously taking place and making your material dried. Now my question is, you tell me and predict at this particular time and write to me in the chat box, this tray dryer is batch process or continuous process? My question is, by seeing till now, you write in the chat box, tray dryer is batch process or continuous process, immediately out. So Shyamala, you that Sri Lakshmi has predicted correctly, but only the thing, what is the continuous here it is present? Supply of the air inlet and air outlet is continuous. So if you are writing suffix with the air inlet and outlet is a continuous, the process is continuous for the air inlet and outlet mechanism, because we are continuously giving the air inlet and we are continuously getting the air outlet. So Sri Lakshmi is correct with this aspect, continuous process. But our aim is not supplying of air. Our aim is we want to get our material dried. So our purpose of drying is not the circulation of the air is done to make our material dried. It means I am keeping the wet material here and I am getting the material dried. Now, what I am doing here, I am taking 10 kg of material, keeping in the tray 1 and keeping 10 kg in tray 2, 10 kg tray 3, total 40 kg of material I am keeping here. And continuously I am supplying the air and continuously I am getting it. So according to Sri Lakshmi, it is a continuous air supply is present. But after making my drying is taking place, what I need to do? I need to interrupt the process of air, stop the air supply, open the door, remove the trays, remove all the 40 kgs of material, and again freshly load another 40 kg. It means in this particular dryer, I can dry only 40 kgs of material and one batch. I cannot load continuously. I cannot get tons of the material. Every 40 kgs of batch, I need to stop it. It means, as far as the output is concerned, now we are going to write is a continuous process change to batch process for the unit operation level. In subpart level, Sri Lakshmi is correct. So that is the reason I am asking you to involve yourself. Whether it is wrong or correct, your concept is very much going to be clear. It is reinforced if you are chatting in the box or involving yourself. So what will happen? Your continuous process, if you are doing in the same thing in the GPAT, you are going to lose the marks and negative, you are going to lose the journey now. But now we are giving a tray drying. It is not the air supply in the tray drying. If GPAT says that air supply in the tray dryer is a continuous or batch, it is a continuous process. I did not ask the question air drying or whether I am asking anything. So Sri Lakshmi mentioning it is a continuous process, it is correct. Why it is correct? Air is continuously going and is continuously going, coming out. But our material is interest here. So my question is, if the question is like that, tray drying is a unit operation for the drying the material. So the material drying in this particular case of the tray dryer is continuous or batch. Then it will come as a batch process. Now, in the batch process, what we are taking? We are loading a 40 kg of batches and we are removing the 40 kgs of the out. Now, you tell me in the chat box, anybody you can write, what do you feel the critical parameters? Parameter, do you know? There are variables. In this case, variables are present. So these variables are making my drying process variable in the tray dryer is temperature. Like we are having 4 options. What is the highest rating? So 80% of answer 80. Remaining answer maybe a 10% remaining. Temperature is the yes. Again, Chandu, you are absolutely right. Air velocity. Excellent. Air velocity is very much critical here. If you keep your air velocity 0, you attain saturation within the chamber. You don't get even drying. If you are increasing the temperature also, you don't get drying. I repeat. If only temperature you are maintaining, rising the temperature, you are closing the door, you are not supplying the air. What you are doing is that you are cooking. Just you are cooking your solid. So you are attaining the supersaturation of your Shiva Prasad, you are also right. Humidity. Humidity is a water pressure which is present in the chamber. If humid zone in the atmosphere is very high, you don't get any drying. You will get parameter going to come into the stage of material characteristics also. It means depending upon the type of material you are going to have as a density and fluffy and lightweight. So depending upon that, you have got a porosity. When the porous material, they are easy to dry and their free moisture content is very easy to get extracted. So density is parameter, but I am telling not the value. I am saying the number. I am giving the hint here. Number of trays. Who are that? That's Sukumar. You are too good. And Sri Lakshmi again. Number of trays. Both have given answer. I don't want to make you suffer, but both you will get marks here. So number of trays are absolutely correct. Reason: if you are keeping 10 trays, if I am keeping 1 tray, obviously you have got a difference. Obviously you have got a difference, because I am overloading and I don't have any place to circulate my air. Then what is the speed of my drying? If I'm keeping only one and I'm making entire circulation of the air, it is an excellent. So number of trays is another parameter. Now you say you have got up to 6 parameters. Do you know what is this? Is the one which you are going to be asked in the GPAT. And this is what you've been asked in the working principle and theory behind. And this is what you have written in the chat box is going to help in your pharmaceutical industry and when you are going abroad or putting yourself after B.Pharma. So whatever remaining is what is going to help you gaining a marks or degree, but this is what is the pragmatic way of thinking. Even I did not talk about them and you are giving the answers. It is an excellent one. Now, you make it another one which is also present. See what is that in the inside the tray, which is going to affect. Inside the tray there is a material and density is given by the Chandu. There is no, and another parameter is present inside the tray. One parameter is present. That parameter is also critical. I am giving the hint. Inside the tray, material is present. Yes, size of the powder. This is also, who is this? Sri Lakshmi, size of the powder. Smaller powder is having highest surface area and you will get a more evaporation. One is a material characteristic. So now you see, now you are getting deeper and deeper and your learning is progressing because you are doing in this spray dryer. Next time what you are going to have in the spray dryer, freeze dryer, and what you are going to get a Amul spray and boost and everything what you are getting in the regular one, you are going to touch upon them in the nearby classes. It is really easier for them if you are involving it. The particle size, if it is a smaller, you will have a higher surface area, your drying is faster. If particle size is bigger, and when it is bigger surface and bigger size and surface area is low and your drying. Excellent. Who is this? Reena B. Raju. Your quantity. Yes. This is what I am saying. If I am loading more quantity in the tray, say for example, my tray can accommodate 1 kg also, 10 kg also. Raju, you are Reena B. Raju. So Reena, you are too good. If I'm making the quantity of the tray material present in the tray is more, my drying is slower, obviously. Say for example, if I'm putting my, if your mother says you soak some material in the sun for any material, if you are putting thick material, more quantity in a thick manner, so it delayed. If you are spreading evenly in a small manner, then it is, what is that? If you are keeping in this area of the tray is same. If you are keeping more quantity, what will happen? Your thickness. Excellent. I did not ask some another one. He has added time period, outstanding level. This is the 10th parameter is the time period. How much time you are drying? So arrangement of the particles. Yes, because when you are spreading evenly, because in your practical, I will ask you to spread your, who is this Sushmita? Yes, arrangement of the particles, because you can spread them evenly also. You can spread like hilly region. You see peak and valley you can make it. When your material is wet, it is having like a peak and valley. The peak material will be getting hidden by the material which is acting as a pile. It will be getting delayed. Arrangement of the particles, absolutely correct. So the thickness of the bed, so the quantity of what Reena has given, it will affect the thickness of the bed. So somebody can write it here in the chat box, thickness of the bed. The quantity of the material is linked to that, is the thickness of the bed. The thickness of the bed is going to be also affecting it. Let me write that also, so that this will be registered to your brain, because this is linked to your quantity of material, thickness of the bed. Enter to all. S, thickness of the bed. Thickness, I have not written thickness. Okay, let me make it as a thickness. Okay. Because I thick of bed, it is not communicating any. Because when you're writing, you need to be very fast, you are getting hurry. This will happen. That is the reason I don't want to make it. Thickness of the bed is parameter which you are going to have. Now, the thickness of the bed is very much critical in our pharmacy, because say for example, if I am maintaining thickness of the bed 0.5 centimeters, 0.5 centimeter can accommodate 5 kg. Okay. So if thickness of the bed is 5 kg and my material is it is 0.5 centimeters and it can accommodate 5 kg in one tray. So I am maintaining the thickness as a constant. Now I am coming to the concept, going to be concept from the variable to constant. We are entering into the different phase now. Now my variable here is the thickness of bed and the quantity of the material of Bairaju and thickness of the betty I have added because both are linked. Because I am going to have a batch size of 50 kilo. 50 kilo, I am going to make my thickness of bed is 0.5 centimeters. In the 0.5 centimeter of this tray of a particular area, I can accommodate how much material? Only 5 kg. It means if I am able to accommodate 5 kg means I am fixing the thickness of the bed is constant. I don't want to change it because what arrangement of the particles Sushmita has given is going to be altered if I am not having this maintained as a constant. It will be changing. In some cases, it is higher. It is lower, like that. So I am making this as a constant. This variable of thickness of bed is a constant now. When I am making a constant this variable, I can accommodate per day 5 kilo. Now you tell me, my total material is 50 kilo. I can accommodate per tray 5 kilo. How many trays I need to use? 10 kilo. Susmita, you are right. Because now you are able to decide 10. So you are Suvarna Lakshmi and Shiva Prasad, you are right. 10 trays are now, you are entering into the production now. Now you are telling your subordinates, you are going to take 10 trays, my dear. You tell your subordinate because you want to become a manager or a leader, group leader. So what you do? You don't want to do it. You will get the work done from a layman or illiterate to get that work done. What you require to do? You need to tell that scientifically what you are keeping as a constant, what you are varying it. Okay. Now you are keeping a variable. Now it is a thickness of the bed, making it a constant. Now once you are making it as a constant, if your batch size is fixed, it is also fixed. If it is 50 kilo, you can take 10 trays, which is making your suitable to accommodate for that particular batch. Which means in this particular case, how much batch size you can do? You are taking 10 kg, 10 trays, each accommodating 5 kilo, and total batch size is 50 kg. Now you tell me the tray drying process, the drying which is taking place is a batch process or continuous? If it is a batch process, you write a batch. If it is a continuous, you write it as a continuous. It means per one time you can accommodate 100 kilo only, not more than that, because you have fixed your drying bed 0.3 kilo. Your dryer capacity is only accommodated 20 trays, not more than that, because it has got some space inside it, not more than that. It means 20 into 5 kilo is 100 kilo. So the batch size for this particular dryer is 100 kilo. It means it is not a continuous process, it is a batch process. It can accommodate only